everyone, thank you for joining us today. My name is Manam and today we're going to be looking at specific heat capacity and how that relates to thermal energy. So we have a few line injectors and that's to define what specific heat capacity actually is, to understand what factors affect thermal energy, and to recall that thermal energy in joules is equal to mass in kilograms multiplied by specific capacity, which is in joules per kilogram degrees Celsius, multiplied by change in temperature theta, which is also in degrees Celsius. So if you're ready, let's get right into it. Okay, so now let's have a look at what specific heat capacity actually is. Now, specific heat capacity can just be defined simply as the amount of energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. Now, these two ones are very important because they will actually give you the idea that it's energy we're talking about. So 1 kilogram of substance by 1 degree Celsius is a very important piece of information that you always need to remember to include in the definition, otherwise you don't get the mark. Now, what factors affect how much thermal energy is actually required to raise the temperature of a substance by 1 degree Celsius? Well, there's only two you need to know about, and that's the size and the actual material of the object itself. Now think about it, right? They had one very large cube like this, right? So these are both solid metal cubes, right? And I put them over a gas stove. Which one of these two do you think is going to heat up fastest? Well, that would be the smaller cube, right? That's really because it's a smaller mass, and so it will take overall less energy to actually penetrate the entire cube itself and raise the temperature of the cube. Whereas the larger cube has more mass, it can absorb more heat before it actually starts to raise the temperature. Okay, first thing affecting how much thermal energy is required to raise the temperature of a substance by 1 degree Celsius is their size. Now, our second one is material, and this really boils down to the specific heat capacity of material. Some materials, such as water, so we can also liquids also have specific heat capacities, or rather we're looking at solid water here, so ice have very high specific heat capacities. Like the specific heat capacity of water is something around 4,800 joules, which is a huge amount compared to some metals which are only 600 joules per kilogram degree Celsius. So our second factor that affects how much thermal energy is required to raise the temperature of a substance by 1 degree Celsius is the actual material itself. Some materials have very high specific heat capacities, which means they have to have a lot of energy, and some have very low specific heat capacities, which means they need not that much energy to change the temperature at all. Now let's actually have a look at the capacity equation itself. We have delta E equals m delta theta. I don't have the delta in my learning objectives, but the delta is usually there. Now, what is delta? Well, delta is just the Greek symbol for change in. So wherever you see this triangle here, this means change in. So really, if I read this out, this means the change in thermal energy is equal to the mass multiplied by specific capacity multiplied by the change in temperature. So that's what our theta here, another Greek symbol, represents. So that represents. So let's have a look at our units now. So delta E, energy, no matter what type of energy, it's always joules. Mass, always kilograms, standard unit. Specific heat capacity, this is a bit weird, but this is joules per kilogram degrees Celsius. And I'll show you how you can remember that. And our temperature is just in degrees Celsius. Now, let's say I rearrange all of this for specific heat capacity C. So what I get then is delta E over m delta theta C. Now, say I write this in its units form, where I get joules over kilogram degrees Celsius equals a specific heat capacity, and that equals joules per kilogram degrees Celsius equals specific heat capacity. So if you ever forget, the units for specific heat capacity, you can just rearrange it and just figure out the units, substitute them in, and write it like that. Now you understand specific heat capacity, which is the amount of energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius, and the two factors that affect thermal energy transfer. Now let's have a look at our worked example. As always, we're going to highlight all of our keywords. So the electric kettle shown below is used to boil water. After the water has boiled, the temperature of the water decreases by 22 degrees Celsius. The mass of the water in the kettle is half a kilogram. The specific heat capacity of water is 4200 joules per kilogram degrees Celsius. Calculate the energy transferred to the surroundings from the water. Okay, now some people might get confused with the surroundings word here when we've just been talking about energy going into a system. But here we can see that the temperature decreases by 22 degrees. That means that energy is actually leaving the system because our system, the water, is losing energy, and so losing thermal energy, sorry, and so its temperature is dropping. So all we do is use our normal heat capacity equation, which is delta E equal to mc delta theta. Now let's substitute all of our values in. So our mass is 0.5 kilograms, so let's do that. And then our specific capacity 400, then our temperature change, which is 22, and that equals 46,200 joules. Right there, and again, it's already in our answer line, but always be careful. That, sorry, 46. Again, straight away, that could have been a mistake you make in your exam itself. I've done it myself many times as well. Always be sure to make sure you're actually writing down your answer and not just some random value. So I hope you understood that.